Hello, Algebra 1 students. Here we are discussing more factoring. We are in Chapter 8, and we only discussed it a little bit in class, so I wanted to go ahead and give you a little bit more sample problems. We're looking at problems that look like this. And most of the time we're going to look at things like this when they're actually equal to 0. Anytime we have a polynomial of degree 2 where the variable goes down by 1 every time, like that, and this is our general form of it, we're going to call this a quadratic equation. And often we can factor quadratic equations with the method that we've talked about a little bit in class and that we're going to talk about again now. Now remember, when we're FOILing out something, we often got an answer that looked like this. And we got this middle term, do you remember, by adding two other terms together when we added the like terms. So we're going to look for two numbers that add to the middle one, but multiply together to give us the last number. Okay, so what do I mean by that? Let's take a look and do a couple of sample problems. The first sample problem I want to do is at the top of page 486. We're going to factor x squared plus 9x plus 20. And remember, I said we want to find two numbers that multiply to be this last number and add to be the middle coefficient, not including the x, just that middle coefficient. So in this case, I want to find two numbers that multiply to 20 and add to 9. What numbers multiply to 20? Well, we can say 1 times 20, but when I add that, I get 21. Or I could say 2 times 10, but when I add that, I get 12, so neither one of these are the things that I want. Or I could say, well, 3 doesn't multiply into 20, but I could say 4 times 5, and when I add these, I get 9. So that's what I want, because I have two numbers that multiply to get 20, they multiply to get 20, and they add to get 9. And once I know what those two numbers are, then my factoring is really, really simple. All I have to do is write my two sets of parentheses with my x first, and then a plus 4 and a plus 5. And just because it's good to double check to make sure we got the right thing, let's FOIL these back out again and make sure that we get what we started with. So x times x is x squared. X times 5 is 5x. 4 times x is 4x. And 4 times 5 is 20. And we're going to add those together. Our like terms are in the middle, so we get x squared plus 9x plus 20. Ta-da, just like what we started with. Isn't it neat how that works out? Let's try a couple of more examples. I want you to do 1A on page 486. Pause the video, and when you're done, get started again, and we'll see if you got the right answer. So go ahead and pause. And now we're going again, and we have a d squared plus 11x. There's a typo in my book. It should be 11d plus 24. And I want two numbers to multiply to 24 and add to 11. So multiply to 24 and add to 11. 24 is 2 times 12, but that's 13. Nope, not what we want. 24 is 3 times 8, and that adds to 11. Ah, we got it already. So that means we're going to do a d plus 3 and d plus 8. And indeed, that's d squared plus 8d plus 3d, that's 11d, plus 24, we get what we started with. Easy peasy. Let's try another one. 1b, again, pause the video. We're going to do 1b on page 486, 1b. And to get going again, in your book you have 9 plus 10t plus t squared. They're trying to trick you, but you're just way too smart for this, because you know that if I'm going to write a quadratic equation, that we want to start with the highest degree term. So we're going to write it like this. And now it's simple because we know we want numbers that add to 10 and multiply to 9. So add to 10. Oh, we usually write the multiply first. Multiply to 9 and add to 10. Well, 9 is 3 times 3. And when I add that, I get 6. That's not what I want. How else can I multiply to get 9? How about 1 times 9? And when I add that, I get 10. Yeah, that's exactly what you want. So t plus 1 times t plus 9. And just to double check to make sure we get the same answer back, t times t is t squared. 9t plus 1t is 10t, and plus 9. Ta-da! I told you this step was fun. Okay, let's move on to another kind of example. I'm going to example 2 in your book. We have x squared minus 8x plus 12. Again, we're going to follow exactly the same methodology. We want to multiply to 12 and add to a negative 8. This looks a little different because now we have a negative number, but really it doesn't change anything. When I multiply two numbers to get 12, two numbers like 6 and 2, 6 times 2 will be 12, but 6 plus 2 is 8, not a negative 8, right? But I can make both of them negative, negative 6 times negative 2, and I get both. When I multiply these, I still get a positive 12, but when I add them, I get a negative 8. We don't like this one. We do like this one. Then we put it in here, just like we would have the other one, and that's our answer. X squared minus 6x minus 2x is negative 8x plus 12. Bingo, that's all we need. You try 2a on the bottom of page 486. And here I go doing 2a. 21 minus 22m plus m squared. The book didn't trick you this time, did they? You know you just need to rewrite that so that the highest degree term comes first. And remember to keep your signs with it. Okay? What do we need to do? We need to multiply to 21, and we need to add to a negative 22. Well, let's see. 21 is 3 times 7. When I add that, I get 10, not what I want. How about, let's see, is it obvious to you? Did you already figure it out? 1 times 21 would add to a 22, not what we want because we want a negative 22. So negative 1 times negative 21 multiplies to a positive 21 and adds to a negative 22. There we go. M minus 1 times m minus 21. And I'll let you check the work to make sure that that's what we need to get. 2b, let's do 2b here right at the bottom. 2b, pause the video and start when you're ready. W squared minus 11w plus 28. Multiply to which number? Which number do I want to multiply to? Multiply to 28, add to a negative 11. 28 is what? 2 times 14, that would be a positive 16, not what I want. How about 4 times 7? That's 11. Okay, negative 4 times negative 7, negative 11. So w minus 4 times w minus 7. It really is as simple as that. Okay, another example on page 487. We have x squared plus 2x minus 15. Same exact sort of problem-solving approach. We want two numbers to multiply to that number without the variable, negative 15, and we want two numbers that add up to a positive 2, just that coefficient. Remember, don't use that x because that's a part of the quadratic equation. We're only looking at the coefficients here. So 15, what numbers multiply to 15? And it has to be a negative 15. That's important. So we could say that it's 3 times 5, but that doesn't multiply to negative 15. So if I make it 3 times negative 5, then it does multiply to negative 15. 3 plus negative 5 is negative 2. Not what we want. How about negative 3 times a positive 5? Again, they multiply to a negative 15, and when I add them together, I get a positive 2. That's more like it. That's exactly what I want. X minus 3 times x plus 5. And I'll double check that. X times x is x squared. 5x minus 3x is 2x. Negative 5 times a negative 3 times a positive 5 is negative 15. Again, no problem. We can do these. Another example, x squared minus 7x, minus 18. Same thing again. Negative 18 is what we want to find numbers to multiply to, and we want them to add to a negative 7. What do we multiply to get negative 18? 6 times 8. Oh, that's not right. 6 times 3. 6 times 3 is 18, but one of them has to be negative in order to get a negative sign there. So if we say negative 6 times 3, that's negative 18. Add these together, we get negative 3. Not what we want. How about negative 2 times 9? Multiply them together, you get negative 18. Add them together, you get a positive 7. Looks like we're getting somewhere, but our signs are still mixed up, so we're not right. Let's try 2 times negative 9. That would be a negative 18, and negative 7 is what we wanted exactly, so we know that we're going to have an x and an x. 2 is positive, and 9 is negative. X squared, negative 9x plus 2x is negative 7x. Negative 9 times 2 is negative 18. That's exactly what we need. I want you to do 3a on the bottom of page 487. 3a. Pause the video and start again when you're ready. We have y squared plus 13y minus 48. Same thing. I know I keep saying it's the same thing over and over again, but that's what all these problems are. We want two numbers to multiply to negative 48 and add to a positive 13. What multiplies to negative 48? Well, how about 6 times 8? And I'll make one negative. That multiplies to a negative 48, adds to a positive 2. Not the combination we need. Anything else? What else could possibly multiply to a negative 48? Well, 4 times 12 would multiply to a negative 48 and make the 4 negative. That would add to positive 8. Still not what we need. What else multiplies to a negative 48? Well, 2 times 24, and I need to make one negative. That's going to give me a 22. Still not what I want. How about, well, let's see, 16 times 3. That multiplies to a negative 48, and when I add these together, I get a negative 13. Oh, I'm on to something now. I know I just need to change the sign, so it's going to be 16 times a negative 3, which is going to add to a positive 13. So I can factor this to y plus 16 times y minus 3. And now you can see one of the reasons why it's so important to know your multiplication tables and to be able to think about these things pretty quickly, because the quicker you can do this and go through all the possibilities, the quicker your homework is going to be. And it's pretty painful to do all of this on your calculators, so practice your mental math and this homework will go much, much faster. One other example I wanted to give you is example 4 on page 488. We have x squared plus 6x equals 27. Well, the problem with solving this is, well, first of all, we don't have it equal to 0. Our method really only works if the whole thing is equal to 0. So we can make everything equal to 0 by subtracting our 27 off of both sides, and then we get x squared plus 6x minus 27 equals 0. And now we can factor the left-hand side. Again, we want two numbers to multiply to a negative 27, and we want those two numbers to add to a positive 6. What numbers multiply to a negative 27? 3 times 9. oops, I'm having issues tonight. 3 times 9. And I want to make one of my numbers negative, so I'm going to make that second one negative. When I add them together, I get a negative 6. Just made the wrong one negative. So it's going to be negative 3 times a positive 9. We'll multiply to a positive 6, and that is our solution. So it's x minus 3 times x plus 9 equals 0. And now we can use our zero product property to actually get better a full solution instead of just a simplified expression. Because we have an equal sign, we can get a solution and not just an expression. So because this equals 0, that means that one of those numbers has to be 0. That's the only way that I can get a product that multiplies to 0. So either x minus 3 equals 0, or x plus 9 has to be 0. And we have 2 solutions. And here's a hint for later on. Anytime you have a quadratic equation, anytime you have an equation with a degree of 2, you're going to get a possibility of having 2 solutions. Every time that happens, there's a possibility you could get 2 solutions. Sometimes it's going to be 1 solution. Sometimes there will be no solution. But there's a possibility for 2 solutions. And I can't wait to show you how that works when we get, I think it's in chapter, it's not in chapter 9, it's in chapter 10, I think. So in your book, on your own, I want you to do 4a. Pause the video and come back when you're ready. 4a is z squared minus 3z equals 70. Again, it only works when we have something equal to 0. So z squared minus 3z minus 70 equals 0. What multiplies to a negative 70 and adds to a negative 3? Multiplies to negative 70. Well, I could say 7 times 10. And I'll make that 7 negative, so I can multiply to get negative 70. And when I add them together, I get a positive 3. Or I could do 7 times negative 10, and that's negative 3. There we go. We don't like that one. We do like this one. So that's going to give us z plus 7 and z minus 10. Is still equal to 0. So now we say z plus 7 equals 0, z equals a negative 7, or z equals 10. I'm going to assume you knew how that showed up. So again, we get 2 answers here. I'll also do 4b for you. 4b is, pause the video and come back when you're ready. This one, they already put it together for you, so you don't have to do quite as much work. And we want to multiply to negative 18 and add to 3. Multiply to negative 18. Let's see, 2 times 9 adds, negative 18. So negative 2 times 9 adds to 7. 3 times 6, let's make that a negative. Add it, there we go. So that's going to be x plus 6 and x minus 3 equals 0. So x could be a negative 6 or a positive 3. Those would be your 2 possible answers. I hope you enjoyed this lesson. Have fun doing it. We will see you in class on Tuesday, and I answer lots of questions that you might have by then. Okay? Good night.